All right, so we integrated. We used our y of 2 equals negative 1 to find our c. And once we have our final solution for y, we take 3 and plug it in for our x. And we can find y of 3. So 2 times 3 squared minus 5 times 3 minus 7. What is 3 cubed? 27 plus 2 times 9 is 18 minus 15 minus 7.
So that would be negative 22.
So I've got 27 plus 18 is 45 minus 15 is 30 minus 7 is 23. All right. Now, while we know how to do this process from before, that has quite a few steps in it. And it would be great if we could do it in a little bit shorter way. And good news, since we have the fundamental theorem of calculus, we can. Okay? So essentially, the fundamental theorem of calculus, we already know that is like where we have our boundaries, and we do f of b minus f of a, right? So what it allows us to do is what this is called out of the textbook, accumulation applications. Essentially, it's saying if you know what the function value is to a certain point, you can start at that point and then integrate from there, so that you're not having to do an integral and solve for c and then plug in a number. It shortens your process. So what we can also think about the fundamental theorem of calculus as is the amount of change theorem. So if they ever ask you the amount of change, or you're solving for the amount of change, or you're using the amount of change to find a new value, we're still using fundamental theorem of calculus. So what it allows us to do is if you know and you're given f prime of x, okay, that is also known as the rate of change, right? We've used rate of change as the slope. This is the slope of a tangent line. Rate of change of a function is f prime of x. You can then find the amount of change. There's not enough blanks here just because life. Of f of x from A to B. Totally not enough blanks. It's fine. All right. In other words, and the mathematical stuff always makes more sense to me than like the words here. So just, I'm with you on that one, because right now you're like, huh? What's this saying? So this is what the fundamental theorem of calculus tells us. You can integrate f prime of x from a to b by doing f of b minus f of a. Yes? Okay. Okay, so here's what we really have. This is our fundamental theorem of calculus. We already know that formula. That's not new to us. What you can do with it, though, is you can solve it for f of b. If you solve it for f of b, it's moving that f of a to the other side. So you could say another formula that comes from this is that f of b is equal to f of a plus the integral from a to b of f prime of x dx.
Would you only use this if it gave you the derivative?
It would only be used if you were given either the derivative or like a graph where you're finding the area under the curve. You could do that with that too. We'll see that here. Essentially what this is doing for us is shortening the process of what we did back up here. So we said back up there, we did a bunch of other things to find this. We indefinite integral, we found our c, we then plugged in 3, and we said it'd be great if we could do this shorter. Well, if you know this, y of 2 equals negative 1, essentially what this new formula tells us is we can start at y of 2 and then just find the amount of change from 2 to 3, and it will give me y of 3, the new value. So what that will look like is saying, if you know y of 3, you can then say or you don't know y of 3, you know y of 2, right? So you're wanting to find y of 3. You can start with what you know, y of 2, and then say, if I can just find the area under the curve from 2 to 3 of my y prime, it was called y prime, yes? Yeah.
No, but this is like if you don't know y of 3.
We didn't know y of 3 in that first example,
But
right?
since we know y of 2, that's why it's plugged in.
Mm-hmm. Yep.
Oh.
So it's essentially saying, rather than doing all the 3 steps we did originally, and we knew how to do those, and that's fine, but it's shorter to say, if I know y of 2, I start at y of 2, and then I just find the integral from 2 to 3 to add the amount of change from 2 to 3, and it gives me y of 3.
So whatever gives you the answer, you plug in for the A, or is that not?
Yes, typically that's what you plug in for your f of a. That's like your starting point. So what that would look like here is then to say, okay, I know what y of 2 is equal to, right? Y of 2 is equal to -1. So that's kind of like our starting point. We're starting at -1, and then we're just going to integrate from 2 to 3 because that's the only part that we really need to know now. So we integrate from 2 to 3 and say, okay, this is going to be x cubed plus 2x squared minus 5x, all evaluated from 2 to 3. So then from there, you're only doing the integral for the short section there, and you're just using your starting place to add that in.
So do you just ignore the -1?
Essentially, it just kind of hangs out to the side until we're done.
Okay. So
Okay? Right. You don't have to solve for the plus c. You don't have to go through all those 3 steps. It's like one step here, and that's it. So this then would be plugging in your 3 and plugging in your 2. That is, if I plugged in 3, I'd have 9 plus 18 minus 15.
Wait, isn't it? So
No, 27. Thank you. 27. Minus, in parentheses, my plugging in of 2. Bless you. 8. Bless you. Minus 10. So then I get -1 plus, I would just do the math within this and say, okay, 27 plus 18 gives me 45 minus 15 is 30 minus 16 minus that is 6. Bless you. So -1 plus 24 does give me 23.
how is that easy right now? Because you don't have to solve for the 3.
2 is a great example of why you would do this. Okay, we do not know how to integrate sine of x squared by hand. So the option of integrating sine of x squared, doing it as an indefinite integral, using your plus c, plugging in your -5 and 2 to get your c, and doing all that, the option is not there for us. So rather than that, we're going to set up this accumulation part of it, and we're going to use the formula f of b is equal to f of a plus the integral from a to b of your derivative. So now let's apply that formula, which you don't have to write down that formula. I'm writing it down so you can see it and how my setup is going to look. But we're going to use that formula using our specific information we have here.
If you use this, is it like the average rate of change or whatever, like where you have to write down that formula to show it?
You will need to show your setup, yes. Otherwise, you're going to have, and you'll get used to writing it. Trust me, it will just come like we know exactly what
do
we're
you have to
writing.
write that or just
Not that
plug it?
with the plugging in.
Okay.
Yep. So you do not have to write that. I'm just writing it so you can follow with me. So in this problem, what is, and remember that f of b and f of a go in order. So let's think about what's f of b, what's f of a, and so on here.
Well,
So f of b has to be f of 2, right? Because it's greater. Does that make sense? 2 is greater than 1.
it always has to.
It always has to be. Yep. Otherwise, it doesn't work. So we have to set this up and know, because you can use this to solve for f of a, or you can use this to solve for f of b. We used it the other way just a minute ago. But let's just set up what we know. It would have to start with f of 2, because b is larger than a every time. Therefore, f of a would have to be what in this case? F of 1. And then the integral would look like, not equals, plus, the integral from what to what? 1 to 2 of, what's our derivative? Sine of x squared dx. Are we all okay with our setup?
Yes.
All right, so now let's ask ourselves the question, what do we know right now? Do I know f of 2 or do I know f of 1? F of 2. I know f of 2 is -5. I would like to find f of 1, yes? So before I ever type this in my calculator, I want to know essentially what I'm solving for so I know what's my variable. I would like to solve on my paper for what I'm solving for before I type this in my calculator. So how do I get f of 1 by itself right now? Subtract the whole integral to the other side. Are we okay with that?
You want to get f of 1?
Yes, because that's what we are finding.
Oh. Yeah.
So if I'm finding f of 1, this can be manipulated a whole lot of different ways. So I'm just going to move the entire integral to the other side. Are we okay with that?
You're looking
Okay,
at
I see.
All right. Now, I'm going to pause for a minute so that we can get our calculators out, if you don't have them. All right, so when I start typing this into my calculator, I'm going to lead with -5 minus, and then I'm going to put the integral in, because this is why I solved it on my paper, so I know what order I'm putting this in my
Are you
calculator.
putting this on the graph?
Nope, not in the graph. Regular calculator part, because this is just numbers. Okay? So in the regular calculator part, we're going to put -5 minus, and then under the math menu,
no.
right under the numeric derivative, there is the fn int,
You
right?
put it in parentheses or
You're hit enter and see what pops up. You do not need parentheses.
no?
You should get a full integral sign with boundaries and all that. You're going to put your boundaries from 1 to 2. You need sine of, in your parentheses there, x squared, and you need dx. And the calculator will do your full integration for you.
Oh, wow.
And I get in my calculator, f of 1 is equal to -5.4945. Is that what we all got? If you didn't get the right answer, you're probably not in radians. Be careful. Okay? Is equal to. All right, so the other reason that we need this formula is for stuff like this. We have no derivative formula here, but we know the integral still represents the area under the curve. So if you're given initial information, like you are here, you can use this to solve for other f of values. So we are given in this one f of -2, f of -2 is equal to 5. So I would like to find f of 0. So I'm still going to be thinking, and again, you don't have to write this part down, but I'm still thinking, how does this apply to my f of b is equal to f of a plus the integral from a to b of f prime of x
You'd have
dx.
to put the -2 in the f of a.
Okay, so -2 is my f of a because 0 is after -2, yes? So let's set it up for just part A. Get in the practice of just writing this formula down every time, whether you feel like you have to or not.
Can you skip
Okay.
to the, like,
So you can go
5?
directly to f of 0 is equal to
5?
f of -2. I would show this first.
You would?
Because sometimes you don't know which parts you have and what you need to solve for. Like that last one, we had to solve for something different. And so then this integral is going to be the integral from where to where? -2 to 0 of f prime of x dx. All right, now let's go to what we know. Now we know f of -2 is what? 5. And while you don't have a formula to integrate, you can use area under the curve. We want the area under the curve from -2 to 0. So let's look at our equation or our graph here. That's going to be this area, right? So that then changes to my triangle formula. 1/2 base times height. It's good to show your setups on those, just to show them that you know I'm not integrating a formula. I'm using my area under the curve, and that area is a triangle. Like, that's great to show. Huh?
How would we show up looking?
Just that, and then go straight to your answer. Yep. So I've got 5 plus 4, which is 9. Now, sometimes these are going to come in multi-part things, where like now in part B, we want to find f of 2. Does that mean I now have to go back to my original f of -2 and do an integral from -2 to 2? No. I now know f of 0. I know f of 0 is 9. We just got that from part A, right? Isn't 0 closer to 2? And I'd have to do like less area stuff. Would it be wrong to go from -2 to 2?
Oh, I see.
No. But you can use what you found now. That's not 2, that's 9. I don't know what I'm talking about here. All right. So I could do one of two different things at this point. I could set up, okay, f of 2 is equal to. I tend to use like the closest one to it so that I'm not doing a whole lot of extra math with area, but it doesn't matter. You'll get the same answer either way, and I'll just show you that. I could say that is equal to now f of 0 plus the integral from 0 to 2 of f prime of x dx. And I could now say, okay, f of 0 I just found is 9, plus my area under the curve is the same thing right there, which is another 9, and that gives me 18. 4? Yes, not 9. Lies. 4. Nope, I'm just going with it. 13. Or, just alternately, and you don't have to do this right now, but I'm just going to say, if you wanted to do f of 2, you could start with f of negative 2. You would just have to do the integral from negative 2 to 2. So that would start with 5, and you would do the total triangle area, 1/2 4 times 4, which would give me 5 plus 8 is 13. Same thing either way. So there's options. Okay, you always have enough information. See if you can set up something for f of 6.
But we could use.
All right, check your answer, and also double check that you did a negative when you did the area of the circle. You get in the mode where you're just like, I'm adding my areas up. Yes, you are adding your areas up, but that's a negative area. So just be careful. That's going to keep coming back to us.
You can leave it at that.
Yes, you have to leave it that. Yeah, that would probably be all wrong. Well, because this is not going to be, I can't see this being that much of like a free response. Like this will come up a lot in multiple choice, and they will have that +1. They will happen. So, all right. Now, I want you to read this this isn't the last one. We'll do one more in a minute. But read this example and try to write a setup for part A. Okay? Don't look at the rest of it, just part A. Yep. So we've got f of 3. You could either set it up originally and then do the minus part, or you could either way. But f of 3 equals f of 0 plus, I keep writing equal signs, 0 to 3 of f prime of x dx. Now, because you're solving for f of 0, there's going to be a subtraction involved here, right? So I could then say, okay, f of 3 is 5 minus the integral from 0 to 3 f prime of x dx is equal to f of 0. All right, so my integral, they give me my different areas. Like this area is this area is this area is that, right? So I'm doing 0 to 3, which happens to be 4. So 5 minus 4 just gives me f of 0 is 1. So then if I want to find f of 7. Okay. Right. So you do have 3 to 7. So you can set it up as saying f of 7 equals f of 3. So you wouldn't have to deal with the 0 to 3 as well.
I'm going to do that.
So you can, yeah, I always will. It's not wrong to use f of 0. I'm just saying sometimes having to add in more things and say, okay, if I'm starting at 0, now I've got to include the area from 0 to 3 and then 3 to 7. Like that just tends to make you do something wrong. So I'm going to set mine up as f of 7 is equal to f of 3 plus the integral from 3 to 7 of f prime of x dx. So this is 5 plus, what's my area from 3 to 7? 9, and it should be what? Negative. They told me the area, they didn't tell me the sign.
That's kind of tricky.
Oh, I know, it keeps coming up.
That they give it to you, but they don't give it to you.
Mm-hmm. I know. So then the best setup for f of 9 would include which one? F of 7. All right. So then I set up f of 9 is equal to. Now, as you get more comfortable, I feel like it would be totally fine to then jump to, instead of saying f of 7, you just start with -4 and then show the integral from 7 to 9. Like, I'd be okay with this. I wouldn't necessarily skip the whole integral thing just because it's like, where are you getting that? Like, where, just throwing a number in there, like, perfect. But, you know, so this would be -4 plus my last area, which is above the curve, therefore it is 2, -2. Now, sketch the graph of f. F is the original. What do we know about f, the original? Let's list our information. We know f of 3 is 5. We now know f of 0 is 1. We now also know f of 7 is, and we know f of 9 is -2. Now, do you know exactly what this is going to look like? Absolutely not, but you do have enough information to draw yourself something. Got to go mark my tick marks here up to 5 and down to negative something.
Oh, I get it.
Is that like put all the pieces together for you? Now we know what we're finding the original points. So that is what this does for us. Look at that. I like when that happens. All right, so now I know one of the original points is at 0, 1. One of the original points is at 3, 5. One of the original points is at 7, -4. And one of the original points is at 9, -2. Now, do we know exactly how this connects? No, but it would look something, whoop, that's really bad there. Something like that-ish, or it could be jagged lines. We don't really know if it makes a sharp turn, but the point is you have the right points. Yes? Good. This also, last and final, lends it to word problems. Okay? All right. So it tells us a pizza with a temperature of 95 degrees Celsius is put into a 25 degrees Celsius room when t equals 0. The pizza's temperature is decreasing at a rate of R equals this. Essentially, decreasing at this rate means this is my derivative, right? You don't have to worry about the decreasing part. It's just saying it's going down in temperature, and that would make sense for like this kind of situation. We would like to estimate the pizza's temperature when t equals 5 minutes. So we want to know essentially on this, whatever you want to call the temperature function, let's call our temperature function P of t. Pizza's temperature. There you go. I'm going with that. We want to know pizza's temperature at 5 minutes. Yes? All right. We have the derivative. We want to know P of 5, but we know now from this kind of information we have to be given something.
T of 0?
Okay? We know P of 0. Now, which of those things is it? Remember, what does P of t represent? The temperature of the pizza, which is 95. And they're going to be tricky about that. Okay, there's extra information there on purpose. So now let's set up that same kind of idea. This is going to be a calculator question. Obviously, we do not know how to integrate e to the anything. Okay, so let's first set up our formula. It would have to be P of what first? 5 equals P of 0, the integral from 0 to 5 of 6e to the negative 0.1 t d what? dt. Now, does that mean we type t's in our calculator? No.
Okay, there is like different letters.
There is.
How do you even get that though?
You use the alpha button, but don't do it. Everything's an X. You're just going to mess with it.
I was just like wondering.
Yeah, no, you can. And people will do it, but it wastes time because they're harder to get to.
Mine doesn't do it.
Alpha something, it should, but I don't know. So P of 0 is 95 plus my integral from 0 to 5, and I'm going to type this into my calculator. And although it says round to the nearest whatever sometimes, it's always 4 decimal places. All right, so we need a negative in our equation, but it should be given to us Because there's another one on the extra practice page, and it has the negative. So, like inside the integral, yeah, -6. If you do that, you get 71.3918 degrees
So you're saying
Celsius.
Give it to you, or
I have never seen it not, but we will look. We will look. If that's something that they should give you, or if the decreasing should just be what made us put a negative.
So is this basically just what our quizzes are?
So your quiz, let me think. I will look.
Because isn't it next